Let me show you what we call the power mode behind computing power.
Why does it require so many generator units? Because an AI computing center is not powered by just one server. It is thousands, even tens of thousands, of GPUs running at full load at the same time once the utility power fluctuates. These massive systems must start immediately, synchronize in parallel, and take over power within milliseconds. Our generator system has 3 core capabilities. First, strong impact load resistance. During AI model training, the load can surge from 30% to 100% within just a few seconds. Ordinary generators simply cannot handle this kind of sudden load shock, but our generator sets are specially optimized for high-impact, step-load conditions. Second, fully automatic startup. Once utility power fails, the system starts automatically and takes over within 10 to 15 seconds. Multiple units run in parallel, with N+1 or 2N redundancy. If one unit fails, the others take over immediately. Built-in capacity margin keeps the system ready for future AI computing growth. Third, intelligent monitoring. Through remote communication interfaces, the system monitors operating parameters in real time. Weekly load tests are carried out regularly to ensure every unit is always ready, reliable, and able to take over when needed. Today, we are not just installing a few generator sets. We are building power support for trillion-parameter AI model training and creating the final line of defense for mission-critical power. What you are seeing now is the batch delivery site of backup generator sets for an AI computing center. Before leaving the factory, each unit has gone through full load testing, synchronization testing, and remote communication acceptance. So once they arrive on site, they can be connected to fuel and power and connected directly into the grid. At the end of computing power lies power. At the bottom of power supply lies backup power. AI is responsible for changing the world. We are responsible for keeping the world powered.